Hey, welcome everyone to class N354 on your computer. Something different we're going to try for this week. This is my second attempt at videotaping myself and these slides, so hopefully this time it'll work. Today we're going to take some time and talk about experimental and quasi-experimental designs. So you can see on the slides that these require that the researcher actively intervenes, such as an intervention, to bring about the desired effect or outcome. That means the researcher has to get in there and do something to make something happen, kind of like an action movie. There's action, there's things happening. It's exciting. These studies differ from non-experimental designs as the researchers does not observe behavior and actions, but acts to make them happen. These types of research studies will test cause and effect relationships, and they provide level 2 and 3 evidence, which are the two highest levels of evidence. If you'd like to look back on some of this, go to chapter 11 in your text, and it'll give you greater explanation. So we've got some cause and effect relationship type things going on here. Three criteria are needed to infer causality. The causal independent and effect dependent variables must be associated with each other. They gotta have a little bit of contact somehow. The cause must precede the effect. The relationship must not be explainable by any other variable, all right? The strength of the conclusion depends on how well other study variables have influenced or contributed to the findings. Something to keep in mind. So think of this while you're reading your research journal articles. You may find these types of studies are often referred to as therapy or interventional studies. All right, so just think cause and effect, you're causing things to happen. Interventional, you're intervening, and that's how maybe it can help it to make sense. All right, you can also look at page 166 in your text for a diagram that explains the study design. Now let's take a peek at experimental design. Randomized clinical trial. This is a type of study that you've probably read about or heard of before. These types of studies use experimental and control groups. You have two different groups. They have a very specific sampling plan that will use inclusion and exclusion criteria. On your quantitative critiques, you may have seen some of this in the studies that you read. Intervention fidelity ensures that every subject receiving the intervention receives the identical intervention. So you've heard me talk about this where it has to be same. Got to treat everyone the same in your studies. And these types of studies will use statistical comparisons to determine any differences between the groups. So numbers. So most likely seen in your quantitative studies, not qualitative. So quantitative numbers. Sample size is important too, and I've kind of mentioned this before. Too large, it's going to waste time, resources, and money. If it's too small, it could lead to inaccurate results because your sample size didn't cover enough population to really verify the results. This study, though, is considered the gold standard. This is your Cadillac in the world of studies for providing information about cause and effect relationships. This type of a trial is often used in drug studies, and I think that's probably where you would have maybe heard about it before. This type of a study can also be referred to as a clinical drug trial. Here's a diagram that will show you basically in simple terms a classic randomized clinical trial. So the sample is selected from the population. Baseline data is then collected. So you're going to get that entry-level data about your study participants. And then it bifurcates. You've got your intervention group and your control group. And then you're going to do post-intervention data on both groups to see how things landed out. These design studies have three things in common. True experimental design has three properties. So you're going to see these properties in all of these types of studies. Randomization, control, manipulation, A research study using a true experimental design is commonly called randomized clinical trial, RCT. We just discussed that a few slides ago. So just remember, these types of studies are going to have randomization, control, and manipulation. Let's look into that a little more. Randomization: each subject in the study has an equal chance of being assigned to the control group or to the experimental group. We're going to treat everyone the same. Equal chance, equal for everybody. Randomization assumes that any important intervening variable will be equally distributed between the groups, minimizing variance and decreasing selection bias. We're going to keep it same, fair, so we can get true and accurate data results. Excuse me. An intervening variable is a variable that occurs during the study that affects the dependent variable. So intervening, something that came in and changed things around. That's all that's saying. Here we've got the big C, the control. Control is introducing one or more constants into the experimental situation. Okay, this is acquired by manipulating the independent variable, random assignment, and using a control group. The control group receives the usual treatment or a placebo. Now we've got the big M, manipulation, not the big M like McDonald's. It's manipulation because we're talking about research studies. So manipulation is doing something to at least some of the subjects. The independent variable is manipulated when some subjects, experimental group, receive the intervention and others, control group, do not. So we're just going to mess around with the experimental group, and we're going to leave that poor control group alone. So I've included a link, and well, you must be pretty good with links because you're able to link up and watch this video. So to get further explanation about manipulation, please press Control and click on the link. I definitely recommend it. Setting up a study is a big deal, and you need to make sure that you have the right number of subjects to prove your data or to prove basically your study, to see what you're studying. So how do you decide how many subjects to manipulate? Treatment effect or effect size? So how many subjects do you need to detect a statistical, remember numbers, quantitative? How many subjects do you need to detect a statistical difference? How do we figure that out? Well, we do something called a power analysis. It's like the superhero of math. It's a power analysis. This is a mathematical equation used to determine the number of participants needed. If you find this information in an article, it means that the researcher took some extra time to ensure that they had an adequate sample size. Usually they bring on a statistician or a mathematician to help them figure out these complex equations. Extra money brought on board to make sure they're doing the study right. Threats to fidelity. Every study has threats to it. We've kind of talked about that. If you have enough threats, it's going to tank your study. So threats to fidelity, what does that mean? Well, we've got mortality. Mortality refers to study participants leaving the study. They could leave because, well, mortality, they died. So mortality, morto, dead. All right. But they can also leave for other reasons. Maybe they got tired of the study. If the study goes on for a long extended period of time, people get sick of it. We're humans. They may say, I'm done with this. I'm out of here. No more study for me. Or perhaps they moved and they're not able to be part of the study, or they become ill and can no longer be part of the study. There are different reasons for mortality and something to think about as you're reading the study. Let's see here. What does the slide say? High probability of this happening in studies that go on for long periods of time. And when reading this type of study, look at the sample and the results. This is so important. See if they report excessive deaths or one group had more dropouts than the other. This will affect the study findings because it's no longer same. Your groups are no longer same. One is shifted in the other, and that will cause an imbalance in your results. Okay? Testing. This is an absolute threat to your fidelity. It's when the same measurement is given twice. Study subjects will usually score better the second time. This could be that they remember the test. So sometimes in studies, the test is given twice, sometimes it's given more than twice, and we'll talk about that later. And what happens is your participants remember the testing measurement or instrument that's used, and they may answer differently because they've remembered the test or because they know the questions. They may answer based on how they think the researcher would want them to answer, kind of that Hawthorne effect that we've talked about before. Researchers can easily enough avoid this by using a different yet equivalent form of the same test for the second or further on set of measurements. Or they can use a more complex experimental design. It gets more exciting. Let's go to the next slide and see. Okay, here's the big one, Solomon four-group design. This type of a study design, it's a big one, and you don't always see it. This type of design will select subjects randomly and assign them to four groups. Four groups, that's big, that's a lot of money, that's a lot of study participants, okay? You're going to have an experimental, a control, experimental after group, and a control after group. The experimental after group and control after group receive no pretest, only post-test. So they're not going to have much contact with research staff before testing or study data is garnered. Controls for testing effects this is done if you think there's going to be a threat to the internal validity. When you see this listed in a study, you got to think about, wow, they laid out a lot of money here. This is more expensive because it requires twice the sample size, and you're going to need more people to process all that data too. If you'd like to look into the Solomon four-group design further, please see page 172 in your text. Well, here's a picture of the big study I talked about, the Solomon four-group design. As you can see, the sample is selected from the population. So the sample meets initial study criteria. Subjects are then randomized. So we've got baseline data collected on the top tier, the top two, and that's your intervention group, your control group, but then on the bottom, no baseline data is collected. So no testing or anything like that ahead of time. So then they each go through intervention control groups, and then post intervention data is collected on all four of the groups. You can't see the bottom one because my head's in the way, but I think you get the idea with this pictogram how the Solomon four-group design is set up and then put into action. So on that same vein, we're going to move on to something called an after-only design, or this can also be referred to as a post-test only control group. And that kind of sums it up right there, post-test only. You get it. This type of study design is often utilized when testing effects that are expected to be a major problem or when outcomes cannot be measured beforehand. This type of study is composed of only two randomly assigned groups, and neither group is pre-tested, so everyone's out of luck with that pre-test. They just don't get it. The independent variable is introduced to the experimental group. Okay, we're going to manipulate the experimental group, but not the control group. This design randomly assigns subjects to the true group, so they are randomized, assumed to lack bias. So they're assuming there's no bias because the only post-test is going to be looked at, and subjects are randomly assigned. The researcher is still able to determine if the intervention created significant differences between the two groups. So they can still get the data they want to look at for their study. So here on the bottom, it says study example would be post-operative pain management only. So you need your patient to go through surgery, so then you can do post-test only and see the ones who were manipulated, if that manipulation brought about different effects versus the ones who did not receive the manipulation. So here's a pictogram of that after-only design. Sample is selected from population. We discussed that. Subjects are randomized, so still randomized, intervention group, control group, and then post-intervention data is collected. So ahead of time, there's no pre-intervention, pre-collection of data. You just go ahead and you randomize, and then you have your independent variable and then your control group, your intervention control, and then you look at what happened afterwards, get your data on the backside. So with anything in this world, there's good and there's bad. What are the strengths of experimental design? Well, it's the most powerful for testing cause and effect relationships owing to the use of control, manipulation, and randomization. Those three key pieces that are needed in this type of study design. The downfall, well, the weaknesses of experimental design is they are complicated to put together. You need a lot of brains to get a study like this up and running. They're very costly to implement. You need more people to run, manage, create, design the study, and then you need more participants. And then after the fact, you need more people to manage your data. Very, very costly, and they can be difficult to implement because you're dealing with such a large amount of study participants. So let's move on to quasi-experimental designs. A quasi-experimental design will also test cause and effect relationships within the study. But in this case, randomization may not be possible. There may or may not be a control group. Lack of control makes evidence provided by quasi-experimental designs less convincing, but it is still considered a level 3 for study evidence. Little give and take on this one. Now we're looking at a non-equivalent control group design. Again, the names kind of give things away. Non-equivalent control group. Experimental and control group, but no randomization. So you've got the true groups, but they weren't randomized. Threats to internal validity include selection, maturation, testing, and mortality. All right. So selection, well, they're not randomized, so they're pre-selected. That's definitely a threat. Maturation, will everyone follow through to the end of the study? And then testing, will everyone be able to go through the testing, or because of the bias in the selection, then maybe the testing won't be as valid. Mortality, they can drop out for a variety of reasons. Results of the study still relatively strong because the researcher is able to compare the two groups on antecedent variables before the intervention. So this is saying that they still feel the results are strong because the researcher compared the two groups before the intervention. So the researcher is going to take a look at the two groups, try to balance them out as best as possible because they're not randomized, and then go ahead and manipulate one group to then get the cause and effect relationship and then study data. So here's a pictogram of that type of study you can take a look at. Again, the name kind of gives us away here, after only design. So this type of study design, post-test only control group design. So randomization is not used and makes the assumption, we're assuming that the experimental and control groups are equivalent. So both of these groups are equal before the introduction of the independent variable. Confidence in the findings depends on the integrity of this assumption that the two groups are comparable. So hopefully our researcher is doing his due diligence on the front end. We've got two comparable groups that we're going to take into the study. This type of design is really quite useful when testing the effects of something that is supposed to be a potential major threat to internal validity. So when would a researcher maybe dip his toe into the water with this type of a study? If a researcher is going to pull out a really big randomized control study, they may do something like this ahead of time to see if they're on the right track with their study design. It doesn't require such a large participant group and can give them a snapshot of future activity on the upcoming study, so they know, do we invest our money this way, or are we kind of wasting our time and have to reconfigure? So that's really when it's used quite often. This type of study design is used when only one group is available for the study, just like the name says, one group only, pre-test, post-test design. Only an experimental group data are collected before and after on the experimental treatment, no control group, and no randomization. Think about your drug trials in this type of a group. Maybe you're testing a chemo drug. Well, you're only going to have that one group and you're going to test it on them. pretest because you need to make sure that they fit your qualifications for the study. Give them the chemo drug, and then post-test did it not work? That's what you're looking for here. Here's a pictogram of that study design process. It's very linear, start to finish. Here you are, end to end. Nothing much going on in between. It's just a straight line. Sometimes a study will use a design to determine trends over a time frame. So that would be your time series design, because one of the biggest parts of it is the indicator of time and the passage of it. This design is useful, such as I said, for determining trends over time. Data is collected multiple times before the intervention to establish a baseline. So that study participant is going to have multiple exposures to research study staff uh, to see, baseline, how are we doing? This type of a study design, though, has a lot of potential threats. The testing, your participants can get used to the test and maybe start giving answers that they think the researcher wants versus what they really want to tell them. Maturation, are your research participants going to make it all the way through? And selection. Hey, are you selecting the right people for the study? These are all potential threats. Here's a pictogram to this type of study. And here it says experimental group data are collected, intervention is applied. Know that the pictogram, I guess they made it this way so it can fit on the page, but oftentimes data is collected more than twice. They have quite a few contact times with the study participants, all right, before the intervention is applied. That's just something to keep in mind. So we've looked at a variety of different quasi-experimental study designs. And these studies do have their strengths. They're practical. They can be less expensive. They can be generalizable to different parts of a population subset. And sometimes the only feasible alternative is this, because these designs are more adaptable to real-world settings. Replication of a study can strengthen evidence. So if I can go ahead and conduct this research study, and then I release my data, and then all of you recreate the same study and you release your data, and we all have similar results, that strengthens the evidence, and it's like strengthens our study and our work. So that's how we would replicate and strengthen the data. Of course, this design method has a weakness, and that's because, well, sometimes you're unable to demonstrate clear cause and effect relationships. We talked about those threats to the study, and they can really affect it. So if you can't carry through, a bunch of your participants drop out, mortality, well, then it's really hard to show clear cause and effect relationships. At this point, go back to the drawing board and give it another try if you still have money. Okay, so looking at the experimental and quasi-experimental designs, these studies are rooted in evidence-based practice, and these studies provide the strongest evidence for making informed clinical decisions. So think about nursing research and nursing practice to bring about change. These are the study design types that you're going to use so you can get those really cause and effect types of relationships and say, hey, this happened, this was our intervention, and we tried it, and you know what, it worked and it really made a change. So we can put this into evidence-based practice and have some new ways of doing things. These study designs are the most commonly included in systematic reviews, so you will see them quite often in your nursing practice. To evaluate these types of study designs, you're going to look at key aspects of the study. So you're going to look at random group assignment. Randomization, as mentioned before, is very important. Adequate sample size. Did we do our power math equation to figure if we had enough people? Recruitment of a homogeneous sample. So did we recruit same, so that everything was equal on both sides of our study? Intervention fidelity, consistent data collection procedures. Ooh, that's a mouthful. Basically, what it's saying is, did we do things the same for our control group and for our independent variable group? Control of the variables. Did we keep everything again, same? And then likelihood of changing practice. Is this going to make a difference? Was doing this study worth the time and energy that it took? Or are we just putting out data about things that we already knew? That would be a waste. So in this class, I'm going to be asking you to critique studies. We've kind of been working on that and already done some of it. So questions you may ask while reading your journal articles is the design used appropriate for the question? So when they were building the scaffolding of the study, did they have the right supports in place to move forward? Is the design pragmatic for the setting or sample? So the design that they've built and put into place, is it going to work for the setting or the sample, such as your population? Okay. Is there a detailed description of the intervention? Has the researcher laid out the intervention in a stepwise manner so that one, it's understandable, and two, reproducible in different other studies to strengthen the evidence and data? As we continue critiquing the data from these types of studies, we also need to look at perhaps a description of what the intervention group versus the control group received. What are the differences? What made these groups similar, but then what was the manipulation that made them different? How is intervention fidelity maintained? So when they manipulated the group, how did they keep the fidelity there so that everything was same within that group? And is there a description of the power analysis, the big math equation? If they used it, they need to spell out the process used in the equation and then show the math of how they settled on the proper number for their sample size. We need to be able to see, or they need to tell us in a very open and transparent manner, what experimental design was used in the study. If you have to really hunt around for the information, then probably the research team is not being very transparent. How were the study participants randomized, controlled, and then manipulated? That's, again, information that needs to be transparent. Are there any reasons to believe that there are alternative explanations for the finding? So perhaps our study looked at men ages 50 to 60 who had low testosterone levels. And we're saying that these low testosterone levels cause them to have poor sleep quality at night. Okay, that's what they're looking for in the study. Okay. If there are other things, such as they have study participants go to a sleep center and they're watched there, and what they don't maybe tell you is a sleep center is located in New York City and it's very noisy there, and they couldn't bring their comfy pajamas and favorite pillow from home. Well, those would be alternative, kind of extraneous things that are going on, and perhaps alternative explanations. Perhaps it wasn't low testosterone that caused our study participants to not sleep. Perhaps it was sleeping in an unfamiliar environment that was noisy, and the pajamas they provided were scratchy, and the pillows were uncomfortable. Well, if those are things that could be possible reasoning in the study, the researcher needs to be open and just lay all of that out for us to discern as we read through their data. As we move down the road of critiquing, I've kind of already hit on this, but it's here again. Our threats to the study validity, including mortality, addressed in the report. We've hit on that. They need to be transparent and let us know what's going on. But the second point is really what we want to focus on here. Are the findings generalizable to the larger population of interest? So let's say we are looking at the men from the age group 50 to 60 with low testosterone and sleep issues. Did they conduct the study in a way that really looks broadly at this group and can then be relatable to a larger population? If not, then the study is very narrow and can only show perhaps a picture of a small group. That way the data just isn't really relevant to anyone other than that small group. Not necessarily worth the time or money to get that data out there. As we continue on looking at criteria for quasi-experimental designs, we have to ask, the data that we're reading, was the quasi-experimental design used in the study, is it appropriate? We kind of talked about that. Were the building blocks that built the building of the study appropriate? What are the most common threats to study validity and findings of the design itself? What are the plausible alternative explanations and have they been addressed? I've mentioned before that in these studies, we really need to look to see if our researcher was pretty open about the work that they did and the work that they're publishing. So when you're critiquing, does the author's explanations of threats to study validity seem acceptable? Is what they're telling you plausible? Does it make sense? Especially in the way they presented it. What does the author say about the limitations of the study? Is a limitation that their sample size was smaller than they had hoped? They wanted 500 participants and could only recruit 150. Those types of things do happen. So look for them. Are there other limitations related to the design that are not mentioned? Sometimes you've got to read through the entire study and look between the lines to see what's missing. What did they not openly talk about in the study? Those can be clues to you of flaws in the study and require just that second look. We've made it to the end of chapter 9. Woo! So, of course, because it's education, I had to throw in a little question here. So, which type of research design is described? A wellness center wishes to determine whether a stress reduction series of classes increases perceived efficacy of participants. A pre-post questionnaire is administered to all participants. I'll let you think this over and discuss the answer. I'd love to hear from you and get your thoughts. So you can definitely hop on tomorrow to my Zoom room and we can discuss. I look forward to seeing you. But you don't have to come. It's just if you want. All right. Thank you.